So the time has come to broaden the perspective even further, and we're going to talk about how technologies from the game industry can be used, well, for different purposes, for other purposes. And we're talking about science centers with a mission to turn complex scientific data into something that is both easily accessible and also attractive for the general public, something that they want to dig into. And here to share some insights around that and also the challenges and the opportunities, we have Patric Ljung. Welcome.
Thank you.
You are a senior lecturer at Linköping University.
Correct.
Yes. And you have also been on a run streak for 2,293 days.
Yes.
Is that correct? Yeah.
That's correct for today. Thank
That's
you.
impressive. I think we'll give him an applaud. Yeah. Both for running a lot and also for being here. Have you had your run today?
Yes, that's
Yes.
why 2,293. Yeah.
Yeah. And how
And I
does
have
your-
a fellow run streaker over there as well.
Oh yeah.
Yeah. He's a way behind though.
Yeah. Yeah. Welcome.
Thank you. Pleasure to be here. Thank you for the introduction. It's a little bit odd to actually be in front of a live audience since like 2.5 years or 2 years in a lockdown or whatever it is. So yeah, I wanted to talk about using a game engine for telling scientific stories and let users explore scientific data. We sometimes call it science communication or scientific communication. So that's the title of this. I want to give you a little bit, as fast as I can, overview what's a science center and what do they do and so forth. Maybe digital science centers, I put it in there to just broaden or narrow the scope a little bit. And then I dive into a little bit about what's visualization really about? What do we mean about that? And then I show you examples of what we've done in a project we worked together with University in Gothenburg. It's not down in Gothenburg, it's to the west, but I often say to the down in Gothenburg. So I come from Linköping University and Campus Norrköping in Norrköping, obviously, where we have the Norrköping Visualization Center. So we're closely affiliated working with those. And the Norrköping Visualization Center is actually a consortium of these 5 partners. But there is a building in which you can go to a science museum. And we can skip this is a little bit of my background, what I've been doing in my life. But the science center, we try to let people explore what you normally can't see. Essentially, a big heap of numbers or simulation stuff that we have that we want people to be able to explore using state-of-the-art visualization techniques. And of course, we have a dome. We have a big dome, seats about 100 people. It was recently upgraded with 6P laser, Barco, blah, blah, full 4K, cinematic 4K, and so forth. So it's a pretty impressive setup, and we support stereo rendering and all sorts of fun. Personally, I come from the Media and Technology division of ITN, Department of Science and Technology in Norrköping. We are a group we have 6 different groups in various areas. I'm in the immersive visualization part. I put in my number, we're 15 because I don't know the current, but in total we're a little bit over 100 people in this division. So we're a fairly big group, and we all deal with various forms of visualization and interaction techniques. And one of the important groups is actually the visual learning and communication. They study how you can use visualization for learning and understanding and so forth. So that's very exciting. So next up is what's visualization? What do we really think about that? So here's an animated little small picture to depict that. We have a lot of data coming in on one side. We have to do filtering, have models that adapts and present data. Then we filter that down. We do rendering of graphical primitives of what it then turns out. In the end, the goal is to reach insight or understand things or confirm things that you want to confirm out of your data. And if things don't make sense, maybe you can turn around the picture, look from different angles, or you can change how we apply the filters, the models, and so forth to trying to understand better what the data is about. And there's also an arrow going back to the data that you want to steer a simulation. You want to control what's happening. You want to send out drones in the environment that's going to capture different data if the existing one didn't provide you with the proper data, for instance. So that's a little bit of a pipeline. So visualization is just not an image showing you a bar graph. It's actually what you understand and the image you build in your head and understand and how you interpret and how you can interact with the data. So interaction is a very core part of what we think visualization is about. So to take a little bit step back, we worked with data that came from medical domain. We developed a virtual autopsy, it was called. So we got medical data from autopsies where they scan the full body or parts of the body, and then you want to explore this. And this was back in 2008 or 9 that we did this, and they actually took my old research software, volume rendering software, and put into this table and added a touch user interface to it. So back in 2009, that was 2 years after the iPhone came and 1 year before the iPad was out, to give you a perspective of how novel touch technology was at that time. But the goal here was to use the same techniques we use for visualization for the professionals and the scientists. The same rendering techniques, the same data, but then adapt it with a easier user interface for people to just walk up and use in a science center to be able to explore this data. And it turned it into an exciting and an explorative visualization here. So of course then it started scan mummies, not scumbags. But mummies, and the same techniques apply, but we had different type of data set here. So that is in essence what we're after here. We want the authenticity of the real scientific data, real visualization techniques that we use professionally in various domains and so, but dress it up with a user interface that lets you create the story or understand and explore the data on your own, or in a group, in a guided situation. So I tried to make an illustration of this very quickly. So we have scientific data, we want to do some visualization of this, and there's either the explore it, or you can use it to explain things. And a few years back, Anders Innerman, the professor at our division, came up with the term exploration. His wife loves when a Swedish invents new English words. Sorry, I was looking at my... so exploration is the word we came up, and it's kind of combination. We tried to embody this into the installations we have done together with Universium that we're gonna see later on. So there's a couple of results you want to do of that. Either you can like dive into the science communication part, or you can look into the research aspect of these. And one of the things I was curious about was, of course, if we do science for the things, can we then easily bring that into the public domain, or not public domain, but for public science centers? Is there a way we can do this more important? And our choice, or my choice, then fell onto Unreal Engine a few years back. And I mean, the things for that, I would say Unity also falls into this, and many other game engines, of course, but these are Unity and Unreal are the two open available platforms for us to use. And we choose Unreal. It's definitely a higher learning threshold to get into it, but I think in the longer term it pays off a little bit. So all of these things are available in there, but there's a few things that's, yeah, it's free in a way and open source. So you can review all the code and you can build it from scratch if you want to. So if you stumble into any issues, you can maybe fix that. But the challenge I had, or looking into this, all of the SciVis tools, all of the InfoVis tools, or visual analytics and software and technologies, they're kind of have their own tools, they have their own platforms. It's not easy to combine with what users maybe otherwise use. And we have a lot of weird things like lots of dynamic geometry, of course. We have data mappings that's not in the vocabulary of a game engine. Odd data formats, we have streaming data. We want to deploy applications without any data. That's going to be loaded runtime later on. Not really how a game engine typically works. You embed all the assets with the package and ship it. We're lacking examples on how to use a game engine for these purposes, and there's no tutorials or guides on how to do things. So it's a little bit left on your own doing these things. Anyway, so that was actually part of a slide I had a few years ago, motivating why use Unreal Engine for visualization and scientific visualization. But 2.5 years ago, we were tasked, thanks to a donation by the Stena Public Visualization Laboratory, or Stena. I should just switch the slide so I can read of Stena A. Olssons Stiftelse för forskning och kultur. Gave Universium and us a large donation to actually develop a new visualization laboratory at Universium in Gothenburg. And we've had our own, in a way, in over 10 years. But now we wanted to really explore this exploration concept and create something novel in a way that we haven't done before. So that was all the excitement of that. And I thought, what a great opportunity to try this game engine concept out to do these things. The traditional way is we had some scientific software and visualizing that, and then we added a UI on top of that, and that's it, we're done. But we had a lot of new challenges to go into this. And I pop up in this exhibit, as you see, there's a lot of about 20 installations, as we call it, or different applications. 7 of those we've done with Unreal Engines. Some are done with web technologies, etc., or a combination web and a homegrown visualization tools, and so forth. So I want to go through and show you examples of these different ones that we've done here. And before I go further, I really want to extend my gratitude to my team that's been working very hard in order to achieve this over the last 2 years. Without them, we wouldn't have been anywhere where we are. And a shameless plug here, we're looking for a PhD student, if you know one. So, kind of sidetrack. So yeah, we have 7 different applications or installations, as we say, because they're built into a physical, like pulpit or whatever. But we have a few here. One is about the ecological network in the Weddell Sea, which is down in Antarctica, that have a lot of interesting things, and that's a network of, I think it's 490 different species, from small single-cell planktons and stuff up to the blue whale or the orca, like a top of the food chain, so to speak. And we want to explore and tell you both how complex that is and also how it's being affected by climate change today. The next application, I'm not sure, did they have an opportunity to test it out there? The climate table for the food? Yes. Good. So we have been showing that up there on the exhibit area. It's a table that kind of comes from an old application we had where you took physical cards, put on the table, they had a QR code on the back, so then they were showing data around that. So this version is now fully digital. It's a touch table. You pull out different consumables or like milk, apples, beef, and see how they affect the carbon footprint, how much land use they take, and how much water usage they take. We also have nutritional information about all of these that we can show. Another one called Under the Surface here is about the Koster Sea. Outside of, on the west side, we have a small picture of Sweden showing you where it is. There's corals, there's lots of things that's been affected by trawlers, fishing and stuff, and damaging the seafloor and so forth. So it's a lot of interesting stuff, and what we have there is thousands of pictures, and we also had video clips, but they weren't structured enough for us to really use. So you can explore those in that application and learn about these different things. Another application is Sweden in Numbers that I'm hopefully going to show you live shortly here if I speed up a little bit. It's about various statistics of Sweden. We have a digital Gothenburg here. This one doesn't really tell you the whole picture because it's a 3D printed part of Gothenburg with we project the data on top of it. So we're trying to illustrate this here. And then we have a green screen studio called Film Studio where you can show videos of things you've produced and tell a story about the data. So there's a big video screen in that. Another application been going under different names like the trolley problem, but the original problem we were looking into was how do you there's a classical problem within AI called the trolley problem, where you're faced of making basically an impossible decision. And how do we want to tell our AI systems what to do in those situations? Are you going to drive into a young lady or a group of people, or are you going to steer off a cliff and maybe then kill yourself? So that's the questions, and there's a fast version where you need to react quickly and just make a choice. The other one, you get an opportunity to maybe think a little bit first. How do you really want to do this? What should you decide? A few techie stuff for you geeks in here about what we've done. We've used Git for version control and management on all these. Every project is their own Git project. Together with a large file support. In Unreal, there's a visual programming technique called blueprints. We've mostly done blueprints, but have some C++ code to do some of the more specific things that's not so easy to do in blueprints. And I mentioned each of these different applications, they have their own project, so they're separate. And some of the installations have a control panel, so there's a smaller touch table for you to control, like the big EcoWeb water of the Antarctica. You will actually interact with that onto a smaller device, and then there's a big curved screen displaying that whole environment that I plan to demo here as well. And we share code and assets between these different by using plugin technology, plugins, and we use a Git submodule technology within those to make that work. And submodules is the only thing that actually works with LFS, the large files support as well. For those who know about Git subtrees as well, that didn't work out. So let's jump into a few of the videos here. First is the Koster Sea that we have here. And you see that the upper part is actually upside down. So we intended to make this at least 2-user installation that you can be on the one side exploring your part and you can explore from the other side as well. So you have 2 sets of usage here. So you can drag over this little viewfinder, find different topics. Some have images, others don't, etc. The climate food, klimat, mat på svenska. Not sure if climate food is a good choice in English though, but it's also around the concept of being able to work on two sides of this table. So you each have a plate on your side, or you can drag out one or two plates. You can also place these items directly on the table and see the data for that particular item, or you can get a combination of those together onto the table. And you see the carbon footprint, the land use, the water use, etc. And there's, I think there's in the data set 120 different items. We haven't picked all of them, but some subset of them from a report based on Mistra. Next is a little bit showing you here the on top to the left is the user interface on a small device. And to the bottom left is what's going to be projected on this large 3D printed table. I think it's about 2.5 or 3 meters squared then. So now it's actually moving around something on that smaller map up there, moving a light source that actually moves around on it. So I'll jump onto the next image actually here that shows you a bigger picture of this. So here we worked with Digital Twin Gothenburg and their partners. So we get a lot of data from like noise measurements and noise simulations, water simulations about how the sea level might rise and how that's going to affect the inner city of Gothenburg. So as you see behind all of these, there is scientific data. There's like resources that we pull together and package into something useful or interesting. I think that was noise actually. And here you see this sea level rise. I think this is by 2100. And we have historical maps, etc. and more. And finally, we have two applications here. One is the Sweden in numbers, and the other one is the Echo Web from Antarctica. And I believe at this point I should try and get over to the live demonstration here. So a little bit of prayer. This will work out. Great. So I'll start off with the Antarctica part. There you go. Right, so here we have a graph. This is actually 490 different species. There are 15,000 connections or interactions between these. Some are oddly though connections to themselves because this species eats its buddy. There are connections that are cyclic. One species eat the other, then the other one eat this one. And stuff like that happens in nature. So not really a clean graph from a computer science point of view. A DAG, so to speak, that we know there's no loops and things, so reality. And this is going to be driven by a separate touch panel in which you get a menu and like can choose different stories here. So this one is most story-based, and I'll actually just pull up that user interface on the bottom corner here. So this is how we solved not being required to run on two computers all the time, but being able to test at the same time. So another bit of techie thing here is for all these, I think we have 1, 2, 3 at least different installations that has a control panel, and the big like Digital Gothenburg is one of those. You have a separate control panel. That's the same application, but you run it as a UI control mode and load a different level in the Unreal Engine. Same thing goes here. And now I put it into a low threshold on when to go to the attraction or idle mode, so to speak. And yeah, work in progress. We haven't done the overall story here, but I jump into a story about the krill. And our goal is trying to explain how this graph relates to the real world and the life down there. So krill is a very important species in the Antarctica ecosystem. I'm gonna touch the right button here until it shows up. So yeah, these are all the species that are dependent in eating krill. Up there is a blue whale somewhere, for instance. And then there's, of course, species that eats what eats the krill. So second level of, and here we show just one other species that's depending on another species that actually depends on the krill eating that one. So you see that quickly evolve into something very complex and lots of dependencies here. And then, of course, krill eats a lot of plankton. Some are zooplankton, some are just vegetation plankton. I'm not sure, or plankton. Zooplanktons are animal-ish. Those are the green ones in here, and we can actually turn around the graph a little bit. That's the plan to have on the user panel here. And then we can look at whoops, that was too fast. See if I can back off to this one again. Yeah, we're working on making sure that you can't click too fast. So there we go. One click. Whoever eat that, secondary level. Then what krill eats. And then there's one species in there. One plankton. Gonna have a picture of that plankton so you will see that. And finally, we have all the species first and second level of dependency of the krill. So of course, if the water gets warmer, probably forgot that, but that little animal there actually lives under the ice, and when the ice melts, there are less of those planktons, which will affect the krill, and they will be less of the krill, and they are a massive resource for the whole protein and the whole eco chain in that area. Should have turned that down. 19. Yeah, I guess I have to skip this one to just give you a minute or two of the other application here. So visual exploration of interesting national statistics, that's the internal name of this. Otherwise, it's Sweden in numbers. And here we have a map of Sweden, and we've gathered data from this Statistics Bureau in Sweden, or Statistics Sweden, I think they're just called. And gathered and accumulated a lot of the data from here. So maybe look at income here. It was more fun before when we didn't have the labels in here to try and figure out which is this county up in this region here that makes a lot of money here, Danderyd. But of course now we tell you it's Danderyd. So their average income adjusted for inflation or KPI som det heter. You can look at how this changed from 1990 and then moving forward to 2017. And I think one very important thing here is to learn an average value. What is that really? Does it say much of reality? No, it doesn't. So you can look at the distribution of these and really see that we have a lot of people up here making over 500,000 of disposable income. Like this, here's the percentage, so it's almost 30% doing that. And you can see how that affects on the females. Yeah, very good, but a few more on the lower income span as well. But for the men, they're all up here in this municipality. And you can see how this changed over the years, and you will notice here that around this period, end of the 20th century, there was a massive change here when you got a lot of rich people living in Danderyd. And I think my time is up, and there's a lot of exciting things to explore here.
It's not really up, but maybe we should have time for.
Yeah, we can. I leave this on, and you can ask me a question, and maybe
Yeah.
we can find the answer here. Otherwise, you can, open for questions.
Yeah. I'm just thinking that I mean, what an important work you are doing, and you really have the power to to make people change their behavior, and they can learn more about the world. I mean, both this that you are showing now, and also the work on visualizing climate changes and how your own choices can affect climate change.
Yeah,
It's
that's
powerful.
very interesting. Yeah,
Yeah.
thank you.
Is it something that you only can see at Universium, or is it online as well?
This is not available online, but you
Yeah.
will be able to see many of these installations in Norrköping as well.
Yeah.
Welcome.
Mm.
And we'll see where it also ends up. But of course, our goal is really to expand and do more and get this to more places.
Yeah.
And I mentioned the dome before. There's another project called Wisdom, in which you're also involved. So there are 4 more domes being built in Sweden to be able to show more of the content that we produce as well. So Gothenburg is one, Malmö, Stockholm, and Umeå, the other places.
Yeah. Great. I feel like I could lose myself in this one.
Yeah,
Just
we'll see.
to-
This might be an iPad app or something. We'll see.
Yeah,
We'll see.
yeah.
That would be fun.
Really fun. Well, there are some questions from the audience. Is there something you find lacking in game engines for the purpose of scientific visualization or visual programming in general, or is it perfect in your eye?
No, there's a lot of things missing, and I would say one of the things is data management. To crunch data from one format to other, summarize it like so. So integrating with other tools maybe, but also how do you get that into the engine? Dynamic data that you don't package with the game. You have to get it in at runtime. I think that's still a little bit of a challenge for us. We dodged some of those bullets, but in the Coster C application, I mean, with the thousands of images, we never thought. So we have about, I would say, probably 6 gigabytes of images. They come with the engine, but they're not packaged as assets, so we read them from as JPEG files at runtime. Whatever you click on, we load them dynamically on the fly. So that kind of things are not so much in there, and of course some thoughts have been you can embed the R language and those tools into the engine, so you can access and execute things using the R engine, for instance. And if you're into statistics, that's a big package of wrestling with data. Another thing that also is not like on the web, you have D3 to draw graphs, like, basic graphs, scatter plots, bar charts like we have here. We have to do that from our scratch, so to speak. So that's actually one of the plugins we created, a graph drawing kit.
This next question is a little bit related to the one you just answered. Do you think or want? Do you think there will be a shift in the game engines industry to lend themselves to more general visual programming?
Certainly, because it's already happening.
Okay. Yeah.
To like film, filmmaking, virtual production parts, live pixels on camera immediately, the auto industry, architecture, manufacturing, lots of areas where we see the engine is being used, not only Unreal Engine, I believe Unity as well.
So it's actually not just a game engine. It's
no,
an
it's
engine
not.
for
It's
a lot of things. Yeah.
yeah, they like it to go. I think Epic call it the creation engine at some point or something. But yeah, it's to me it's an engine for interactive 3D worlds. And I think it's important because you will probably do a lot of various visualizations and use it for various presentations, and you want to have data visualization in there.
Yeah.
So our techniques better work in that context, so you can have that there. Yeah.
Oh, thank you. Yeah, there is a question. If there are plans on making this information public, how long does it require before this can be made public?
The information or the applications?
The information or the applications? Is there
That's a
someone
good
in
question.
here who?
So I can try answer both.
Yeah.
I would say our goal and what we want to do is at least to take some of the parts that's like say a graph drawing plugin or a color management like color maps and stuff that I would hope we can make open source and publish. Other things might be semi-open source or like behind the Epic Games marketplace. Hopefully like free of charge, but still you have to be a registered user somehow. Some of the data is public, like the SCB data you can actually get access to, but they mostly work on the web to get that. Other information is maybe harder to come by and hard to make public in a way. But yeah, that might be done.
Yeah. Let's see. Yeah, you mentioned that you were looking for a PhD student, but you were kind of quick.
Yeah,
so
I
is
was
there
very
something?
quick.
Do you want to say something more about that?
I'd love to.
Yeah.
So the project we have is if you think of it, well, under the premise that VR and AR headsets will eventually have much better, higher pixel density and higher resolution. And if you want to create really beautiful pictures, there's one part of that is you need to do more efficient rendering to actually, you can't render all that in a classic way. You need to focus on these pixels, need really high quality. The other part is if you take a very large scan of the entire Linköping, Norrköping, for instance, such a data set is huge if you want to have the quality as so you can walk on the streets on that context. So that would be multiple terabytes of data. And here the pitch here for a PhD student to work on is by having a somewhat okay resolution, can I determine the parameters and materials to use to synthesize on the fly that gravel ground or that tiled floor or the roofing or the sides of the buildings, for instance? Can we synthesize that on the fly so I don't need to send the actual pixels from the scans out there, but send you a synthesized material? And thus get this size too. Smaller and manageable.
Yeah. Interesting.
Yeah, it's very interesting
Maybe
and
there's
exciting.
someone in here or online listening that will apply. We'll see.
That would be great.
Yeah. So, okay, time is up. So, a big round of applause for Patric.
Thank you.
Thank you